our first chapter, some basic concepts of chemistry is completed. Now come to the chapter number 4, structure of atom. Now this is linked to the first chapter. So we will see this first, and after that we will see the second and third chapter. Now this is the in this chapter there is details about the atom, and in first chapter we already see that atoms are the smallest particles of the elements. Now Dalton says that atom is not divisible, but later the discovery of the three subatomic particles of the atoms. Now this is proved that the atoms are divisible. Now which are these three subatomic particles? You know in the 10th standard, that are electron, proton and neutron. Now these are called as the subatomic particles, electron, proton and neutron. Now there is the different theories about the discovery of these three types of subatomic particles of the atoms. But first see which are the properties of these subatomic particles. Now these are very, you know that atoms are very small particles of the matters, and that is the elements, and the weight of the atom is also very small, you know that, and it is measured in the unified unit U. It is also called as the atomic mass unit, and in kilogram the weight of the atom is nearly equal to 10 raised to minus 24 kilogram. Now these are the subatomic particles, so definitely its masses or the masses of these subatomic particles are smaller than that of the atom. You know that 10 raised to minus 24, that is very negligible. And here again we go to calculate the mass of the proton, electron, neutron, that is below this 10 raised to minus 24 kilogram. Now see what is there, which are the properties of these subatomic particles. Now these three subatomic particles, electron, proton and neutron. Now which are the symbol for denotation of these three particles? Now electron is denoted by E, small e, and the negative sign on that. And these protons are denoted by P, or it is also called as the hydrogen nucleus, and neutron is denoted by small n. Now see the absolute charge on that in the coulomb. Absolute charge in coulomb of electron is equal to minus 1.6022 into 10 raised to minus 19 coulombs. Now as electrons and protons, these are the opposite particles, their charges are opposite, so the magnitude of the charges are same, but only the sign is opposite of that. So the absolute charge of proton is also have the magnitude 1.6022 into 10 raised to minus 19 coulomb, but the sign is positive for that. And there is no any charge on the neutron. You know that neutrons are the chargeless particle, neutral particle, so they are called as the neutrons. And as there is no charge on neutron, so charge is given here 0 of the neutron. Now see the relative charge again. Now these are in the coulombs. Now these are very negligible charges. So the relative charge of the electron is taken as minus 1. And similarly the relative charge of the proton, as they are the positive particles, the relative charge of the proton is taken as plus 1. There is no charge on the neutron. It is chargeless, neutral subatomic particle. So the charge given here is the 0. Now, what is the symbol for charge of this electron proton? What is the symbol? Now, though the charge, relative charge on electron is -1, but symbol for that charge is -e. The proton have the relative charge +1, but the symbol for the charge on the proton is +e. As there is no charge on the neutron, so there is no any symbol for the charge of the neutron. Now, let us see which are the different masses of these subatomic particles in kilogram. Now, in kilogram, very negligible mass of the electron is there. You know that the mass of the electron is 1837 times smaller than that of the proton. So, in kilogram also, the weight is very negligible of the electron. They are very, that is the mass less particle, weightless particle, and so there is no any, that is the meaning of the mass of the electron. But in kilogram, the mass of electron is 10,938 into 10 raised to -31 kilogram. Now see what a negligible mass in kilogram of the electron. This is very still, that is the smaller than the mass of the atom. The mass of the atom is in the range of 10 raised to -24. Now this is in the range of 10 raised to -31. You know that this is very negligible mass. And in unified unit, you know about the relation in the last chapter, in kilogram and unified unit. Now in unified unit, this mass becomes, that is 0.00054 unified units. This is very negligible, so it is for convenience. Approximately mass of the electron in unified unit is taken as 0U. That is 0 unified unit, because this is very negligible mass of the electron. So we always take the mass of the electron in approximate, that is 0 unified units. Now proton still have somewhat greater mass than of the electron, because protons and neutrons are the massive particles. They are present in the nucleus. So collectively these proton and neutrons are called as the nucleons, because they are present in the center of the atom, and that center is called as the nucleus. And as these two particles, protons and neutrons, are present in the nucleus, they both are collectively called as the nucleons. And these electrons are, that is rotated around the nucleus, so they are called as the extranuclear particles, because they are present around the nucleus, so they are called as the extranuclear particles, that is the electrons. Now see, the proton have the mass in kilogram 1.6726 into 10 raised to -27 kilograms. This mass in kilogram is still smaller than the mass of the atom, because proton is also the subatomic particle. It definitely smaller than that of the atom. And in a unified mass unit, the mass is 1.00727 unified unit. Now this mass in the unified unit, as it is 1.00 and 727, so it is approximately taken as the 1 unified unit, the mass of the proton. As proton and neutrons are the subatomic particle present into the nucleus, there is no large difference between the masses of proton and neutrons. Now one theory is there of Yukawa scientist, which is the Japanese scientist. He said that continuously proton and neutrons are converted into the nucleus into each other. In the nucleus, protons and neutrons are continuously interconvertible. into each other. म्हणजे ते एकमेकांमध्ये कन्वर्ट होतच राहतात. नाव mass of these neutron is also that is nearly equal to that of the proton. Now see, only the very small difference between them. The mass of the neutron is 1.6 thousand now 749 into 10 raised to minus 27 kilogram. And similarly in the unified unit, it is also 1.00867 unified unit. As it is 1.00867, so it is approximately, it is also taken as the one unified unit. Now these are the properties of the subatomic particles of the atoms, electron, protons and neutrons. Now what is about their discovery? See, first let us see the discovery of these electrons. Now the discovery of electron is done in the year 1897 by the scientist J.J. Thomson. Now he prepared first or demonstrated first a cathode rays tube, and he then said that the cathode rays are nothing but they are the negatively charged particles, and after that the name is given electrons to that particles. The cathode rays are nothing but they are the stream of negatively charged stream of negatively charged electrons. They deviates the electric field as well as magnetic field, and in the electric field and in the magnetic field the stream of that cathode rays deviates toward the positively charged electrode, and in this way, as they are attracted toward the positively charged electrode, definitely they have the negative charge. In this way, J.J. Thomson discovered the particles electrons in the form of cathode rays, but the cathode rays are found to be they are the negatively charged particles, and that are called as the electrons. Now, how there is discovery of the proton? Now this proton, that is the positively charged particles, they are also called as the hydrogen nucleus. Now when the nitrogen, now see, nitrogen, the atomic mass of the nitrogen is 14, and that of the when this nitrogen, now see here, I rub this, the name of the chapter, and I write here one radioactive reaction. Now how that reaction is in this way. Now see that reaction. Now these nitrogen atoms having the mass number 14 and having the atomic number that is the 7. Now when these nitrogen atoms are transmuted by the alpha particles, you know that alpha particles, that is the Rutherford's experiment. We have know the Rutherford experiment. Into that we know that alpha particles have mass 4, and that is the charge, that is the +2 here. Now when these alpha particles are bombarded or transmuted on these nitrogen atoms, then what happens? There is formation of the isotope of oxygen having the mass number 17 and the atomic number 8. And again some light particles, that is hydrogen nucleus, are that is emerges out. There is the emission of these particles. Now see how this reaction is balanced, radioactive reaction. Now see here, total mass number 14 plus 4, that is the 18. Here also 17 plus 1, 18. Now atomic number 7 plus 2, 9. Here also 8 plus 1, 9. Now see, these hydrogen nucleus, that is the positively charged particles, are emit there, and so many atoms of the different elements are transmuted by alpha particle. All the atoms of different elements emits this hydrogen like particle, that is the positively charged particle. In all or nearly all elements there is that hydrogen, and the charge on that hydrogen is positively. Now this is discovered by the Ernest Rutherford in 1911. Now, from that he conclude that every atoms of the different elements have the positively charged particle, that such as hydrogen nucleus having the mass 1 and charge also plus 1. Now charge. And from that he told us that there is the positively charged particles in the nucleus of every atoms. Again the Rutherford did his famous experiment, that is the scattering of alpha particle. Now when he do that experiment at that time, he see that there is the some of the alpha particle get bounce back from the that is the gold foil into the 180 angle. म्हणजे that means they comes return by the same, that is the way in which they are go, by the same way they comes return in the 180 degree. Now why that happen? So he told us that the every atom have a massive part at the center, and that massive part, that is having the mass, somewhat mass to that part of the atom, and that massive part he called as the nucleus. And after the discovery of that nucleus, he then conclude that in the nucleus there are such positively charged particles, subatomic particles, and he called that is the proton. In this way there is the discovery of proton. Now how the neutrons are discovered? Neutrons are discovered by the James Chadwick in 1932. First Rutherford also tells there must be the neutral particles having nearly mass same as that of the proton in the nucleus, but proof is not there. Then after 1932, the James Chadwick also performed some experiment of the alpha particles. When the alpha particles are bombarded on the beryllium metal, then some unknown particles come through that beryllium metal and they penetrate. Penetrate means they go, they penetrate through the paraffin liquid, and after penetration through the paraffin liquid, the particles which comes are called as the protons. But that unknown particle which penetrate into the paraffin, they do not have the name or which are that particles. Then after some time he conclude that particles are neutrons and they have no any charge on that. They are the neutral particles and their mass is nearly same as that of the mass of the proton. In this way all the three subatomic particles then discovered in 20th century after the discovery of the Dalton. Now these subatomic particles, that of the proton and neutron, they are totally called as the nucleons. Now these particles, they have mass, and so the total, that is the mass or total their number is called as the mass number, and the mass number is denoted by capital A. Now suppose this is the symbol X for any element, then the mass number is subscripted to the super subscript to the left hand side of the symbol of the element, and the atomic number is subscripts to the left side of the symbol of the element. Now this Z is the number of protons, but you know that atom is electrically neutral. Atom is electrically neutral. So how many protons are there are exactly balanced by the electrons there. Protons and electrons numbers are same because atom is electrically neutral. So Z, that is the atomic number. Z is the atomic number. Now this atomic number Z is nothing but it is the number of protons or they may be the equal to number of electrons also, if the atom is there. So number of protons or number of electrons are called as the atomic number, and it is denoted by Z. And this mass number A, now this is nothing but it is the summation of number of protons plus number of neutrons. Now it is called as the mass number, and it is denoted by capital A. So if we want to calculate the number of neutrons from these two numbers, that is the mass number and the atomic number, then how we calculate that? Now number of neutrons n is given by A minus J, because A is the proton plus neutron and Z is only the number of protons. So from that we can calculate the number of neutrons from this formula. Now in this way we can calculate the number of neutrons of any element if we know the mass number and atomic number of that element. And you very well know that this atomic number is very important, because in the modern periodic table, that is the classification of the elements are done on the basis of the atomic number, and the elements, the periodicity of the elements are on the basis of the atomic number. You know that the periodic law of the modern periodic table. First, Mendeleev say that mass number is important, so he give its periodic law in the language of mass number. But after the discovery of that proton, that is the atomic number is very important for the classification of the elements. Now there are some in natural, there are the elements which are found, their atoms are found in 2 or 3 different forms. Why that is so? For example, the carbon have 3 different types of atoms there of carbon, and the very simple example is the hydrogen. Now you know that hydrogen is present into the normal hydrogen having mass number and atomic number same. Now there are in the nature, there hydrogen, some of the atoms of the hydrogen are found into the form, that is the deuterium. Now it is denoted by D. Its mass number is 2 and atomic number is 1, or it is also denoted by H21. They are the hydrogen atoms, only the name is deuterium is there. And third atoms of hydrogens are found into the nature, that is the tritium. Now this tritium is denoted by T31 or H31. Now see here, all the 3 atoms of the hydrogen have the atomic number 111, only change in the mass number. Now these are very in traces amount. Traces means very negligible amount into the nature. But this is the hydrogen, it is 99.90% into the nature. But still they are present. So such atoms of the same elements having the same atomic number but different mass number are called as the isotopes of that elements. Now isotopes in Marathi, it is called as the samasthanike. Now as a hydrogen have the 3 different isotopes, hydrogen or protonium, deuterium and tritium. Similarly, carbon also have the 3 different types of isotopes. Now that are the carbon 12-6, carbon 13-6 and carbon 14-6. In this way, all the 3 carbon atoms here have the atomic number 666, but the mass number 12, 13 and 14 are there. Now such type of atoms of the same elements having the same atomic number but different mass numbers are called as the isotopes. They can be also defined as all the isotopes of the element have the same number of protons but different number of neutrons in their nuclei. They are called as the isotopes. Now there are isobars also. First, let us take some example. They ask us that is find out the number of proton, electron and neutron into the now this nucleoside. Now see that nucleoside means what? Argon 40 and that is the 18. Now if we write such symbol for the element that is the mass number and atomic number, then it is called as the nuclide. Now it is called as the nuclide. Now this is the nuclide. Generally nuclide is denoted as in this way, A, Z. Now this is nuclide. Now they ask us the question, problem number 4.1. It is for 1 mark also come into the examination or 2 marks. They ask us find out the number of protons, electrons and neutrons in the nuclide argon 40, 80 in this way. Now that is very simple. We know that here A is equal to 40 and Z is equal to 18. Now we have to calculate first N. Now N is equal to A minus Z. N is equal to 40 minus 18. So N is equal to 22. Now that is the number of neutrons. As Z is nothing but it is the number of protons also and number of electrons also. So here number of electrons is equal to 18 and number of protons are also 18. Now there such type of problems may be there. Now come to the new concept, that is the isobar as that of the isotopes. There are isobars also. Now isobars are the atoms of the different elements, not of the same element. Isobars are the atoms of the different element. They are not the atoms of the same element. Now here take this example may be there argon. So I do not rub that. And there is the example of this that is potassium is also there having mass number 40 and that is the atomic number 19 of that. Argon that is calcium is also there, calcium, and this is the potassium. Now calcium also have the mass number 40 but atomic number 20. Now see this example is not given in our textbook, but I know that example. Now in the last year this example is given. Now these are the 3 different types of atoms of the 3 elements. One is the argon, that is the inert gas, potassium and calcium are that. Now see that here the number of neutron we calculated 40 minus 18 that is equal to 20. Here 40 minus 19 that is equal to 10 and here 40 minus 20 that is equal to 20. Now these are the number of neutrons. Now in isobars the number of neutrons are different. In isobars the atomic number are also different, but the mass numbers are same. The atoms of the different elements having the same mass number but different atomic number are called as the isobar. In our textbook they give the example of carbon and nitrogen. Now carbon 14 that is also the isotope of carbon because the normal carbon is of the mass having 12 and here the atomic number is 6. Here the mass number is 14, atomic number is 7. Now see, both have the mass number same 14 and 14, but there is change in the atomic number. As atomic number changes, then the number of number of neutrons also changes. Here the number of neutrons, if we sub here there are the totally from 8 there are the number of neutron and here there is 7 number of neutron. In this way the isobars having the masses same but the atomic number different and they are the different atoms of the elements. they are called as the isobars. Now this is sufficient for today. बघा आता